Hello and welcome to part 2 of this IP address series. In this video I will explain what subnetting is and I will show you how to do subnetting. So subnetting is the process in which you break a network into smaller pieces or into smaller networks. Subnetting is done by choosing an appropriate mask called a subnet mask or a net mask to define the number of hosts in that network. The network address of a subnet can be a valid IP address from the subnetted network that devices will no longer be able to use. That means the network address of each subnet is a valid IP address, but before the network was divided or subnetted, this IP address was IP address for hosts in that network. But when we introduce subnetworks, the first IP address is assigned as network address of a subnet. Alright, so we are losing IP addresses. We lose 2 IP addresses for each subnet because the first IP address in the IP address range for each subnet will be the network address. The last IP address in that subnet will be broadcast address of that subnet. So we are losing 2 IP addresses when we create each subnet. To show you how subnetting works, let's see a simple example. So let's say the IP address 192.168.1.130 is in class C network from the range .1.0 to .255 because it is class C network. So these 3 octets are used as a network ID and the last octet is used as a host ID. So it has the mask 24 bits for the network, which is set all to 1, and the last octet all set to 0 as a host ID. The company has 2 different departments, let's say, and they are both in the same network, but it is required that they should be on different networks. So computers in department A should talk to computers in department A only, alright? So they should be in one network and department B should be in another network. So we are basically dividing the company network into 2 sub-networks. When assigning IP addresses, the network administrator uses to assign IP addresses ascending, starting from 1 to department A and descending from 254 to department B. And so decided to divide this class C network into 2 subnets, each containing 128 addresses. So what we are doing is we are dividing this network into 2, which has this natural mask. If you use 24 bits for identifying the network, we use these 8 last bits to identify hosts. Now, to divide this network into 2, what we consider is the last bits, which is 8 bits. So totally we can have 2 raised to 8 hosts or IP addresses in a network. So when you divide that into 2 and assigning computers in the first network starting from 1 and in the second network starting from 254, we will have 2 subnets which will be from 0 to 127 for subnet 1 and from 128 to 255 for subnet 2. Now we said the network administrator assigns IP addresses starting with .1 to department A. Why are we saying .1? Why don't we say from the 0? Because this .0 is actually the network address of the first subnet. So we don't use that to assign 2 computers in department A. So we start from the next number, which is 1, up to 126 in department A, and starting from 254 because it's descending. Again, we are not using 255 to assign to computers because this actually is the broadcast address of subnet 2. So we go from 254 to 129. Again, we don't use 128 because this is again the network address of network 2 or subnet 2. Alright, so in other words, we are going from 129 up to 254 for subnet 2. So in here we are talking about assigning IP addresses to computers in each network. In here we are talking about total IP address range, including the network address and the broadcast address in each subnet. So the example we already saw doesn't show actually how we divide a network into subnetworks. If dividing means dividing into 2, into 4, into 8, and so on and so forth. So what we have seen is just dividing it into 2 because it was simple. So we could just identify the IP addresses or the host addresses in each subnet and the range of IP addresses because it is simple, right? So dividing a 2 raised to 8 IP addresses, which is 256 IP addresses into 2. Is what we have seen. But in general, in order to subnet a network, what we do is we extend the natural mask with some of the bits from the host ID portion of the address in order to create a subnetwork ID. For example, given a class C network of 204.17.5.0, which has a natural mask because it's a class C network. And by the way, if you didn't see part 1, watch part 1 before you watch part 2. Because in part 1 we have seen what subnet masks are, what class of IP address are, class A, class B, class C, and so on and so forth. So in order to understand this video, you should watch part 1. So as we have seen in the last video, in part 1, a class C network ranges from 192 to 223 in this first octet. So this number 204 falls in the range 192 to 223, which is class C. Alright, that's how we can tell whether this is class C, class A, or class B network. So as you can see, this IP address has 24 bits to identify networks and 8 bits to identify hosts. Now, given this mask, you can create subnets in this manner. This is the given IP address, and this is the subnet mask for the subnets we are going to create. Alright, in this example we will see how we can divide a network into 8 subnets by taking 3 bits from the host part, because in here we had 8 bits for the host ID. We will take 3 of the 8 bits to create subnets. We will use only 5 bits to identify hosts. Let me show you how we do that. I don't know what this is. Let's assume this is a circle, the best circle you have ever seen. So we are dividing the network into 8 subnets. In order to divide a network into 8 subnets, we are taking 3 bits, so that means 2 raised to 3 bits is equal to 8 subnets. Alright, now if we change the given IP address, which is 204.17.5.0 to binary, if you change this to binary, we will have 1 1 0 0 1 1 0 0 dot 0 0 0 1 3 zeros 1 dot 5 zeros 1 0 1. 5 is 101, so we are adding 5 zeros to make it 8 bits, and all zeros 40. Looks like 1, but I'm writing 0, believe me. And last. Alright, these are all zeros. Alright, this is binary equivalent of this, and the subnet mask is 255.255.255.224 when we add the 3 bits. This in binary will be 8 ones, dot 8 ones, dot 8 ones, and 224. So we are taking 3 bits from the 8 bits, so 3 ones and 5 zeros. Alright, now what we will do is we divide this network, which has this IP address, to 8 subnets. So let's call this subnet 1 SN1, let's call this subnet 2, subnet 3, and so on until subnet 8. Now if we have 8 subnets, by taking 3 bits from the natural mask, a way that I like to create the subnets from the given IP address is you take these 3 bits in turn. For every subnet, we will change the 3 bits to different combinations. So the first combination is if we make all 3 of them 0. The second combination will be if we make it 0 0 1 0 1 0, and so on and so forth until all of them are 1. So in other words, for subnet 1, we will set these values to 0, which is alright. Subnet 2 will be 0 0 1. Subnet 3 will be 0 1 0. Subnet 4 will be, subnet 5 will be 1 0 0. Subnet 6 will be 1 0 1. Subnet 7 will be 1 1 0. Subnet 8 will be all ones. Alright, now we divided the network into 8 subnets. For each subnet, we can determine its network address, subnet mask, and host addresses. So to do that, for subnet 1, we can find its network address To find its network address, what we do is we take the bits from the given IP address. So the exception is the last octet. So for the 3 octets, we take all the bits. For the last octet, what we do is we set all zeros, because that's subnet 1, okay? So in subnet 1, we set all zeros for the 3 bits and all zeros for the 5 bits to find the network address. So network address for subnet 1 will be dot, in other words, 204.17.5.0, because all the 5 zeros will be set to 0 in addition to the 3 bits. Okay, the 3 bits are 0 already. The 5, if we set the 5 bits to 0, we will find 0 if we change it to decimal. And obviously the subnet mask is common for all of them. So this is network address, this is subnet mask. The IP addresses or host addresses for subnet 1 will be from .1 to .30. The reason why is because .0 is the network address, so the next number to the network address is the first host address in that subnet. .30 is the IP address for the last host in that subnet. So these are host addresses, but if the question is what is the range of IP addresses in subnet 1, that will be different. So that will be from .0 to .31, including this one, okay? Starting from the network address to something called a broadcast address. This is a broadcast address in subnet 1. In other words, the 3 bits set to 0 and the 5 bits set to 1 is 31. 5 for 1 is 31. So that is the broadcast address. .31 is broadcast address. .0 is the network address in subnet 1. So if we eliminate the first and last, because we don't use them to assign to hosts in that subnet, we find from .1 to .30 host addresses. Similarly, for subnet 2, the network address will be, so this is subnet 2. So we are setting the 3 bits we borrowed from the host ID to 001. So this will be 001 and then 5 other values or bits for the host. Now to find the network address, as I told you before, we set the host IDs to 0. That will be 001 and then 5 zeros, which is, if this is 1 and we have 5 zeros, it's 32. So it will be .32. And this is the same for all of the subnets. Okay. Now the range of host addresses will be from 33 to all host IDs set to 1, which is 5 ones, and we have 001 already, which is nothing but 63. So in other words, what we are saying is starting from the network address to the broadcast address from .32 to .63 is the range of IP address. So in other words, we are continuing from the above. So from 0 to 31 is the range of IP addresses in subnet 1. From .32 to .63 is the range of IP address in subnet 2. Always the last host address in a subnet is the broadcast address minus 1. So this will be 62. For subnet 3, network address will be 0, 1 and 6 zeros, which is 64. To make it easier, let's start from the range. So range of IP addresses for subnet 3 will be from 64 from the network address up to the broadcast address. So again, broadcast address is 0, 1, 0 and then 5 ones. 1, 0, 5 ones is 95. That's what 0, 1, 0 and 5 ones is. Now the host address, by the way, this is host address and this is range. So if we deduct 1 from the broadcast address, which is 95, that will be 94. So this will be dot 94. If we add 1 to 64 to the network address, we will find 65. Subnet 4 is 011. So we are setting the 3 bits to 011. If we put zeros to all the remaining bits, we find 011 5 zeros, which is 96. And then the next number is 97 to 126. And the range of IP addresses will be 96 itself to 127. For subnet 5, we have 100 and the rest 5 zeros, which is 128. Host address will be this plus 1, which is 129, till broadcast address minus 1, which is 158, because 100 and all ones is 159. For subnet 6, 101, all zeros is 160. The range of host addresses will be plus 1 to this, which is 161, to 101, all ones minus 1. 101, 5 ones, which is 6 ones plus 128 is 191, minus 1 will be 190. And for the range of IP addresses from 160 up to 191. For subnet 7, 110, all zeros is 192. Host addresses in this subnet will range from plus 1, which is 193, up to 222, because the broadcast address will be 110, 5 ones, which is 223. So minus 1, 222. For subnet 8, the last subnet, the network address will be 3 ones, 5 zeros, which is 224. Subnet mask is the same for all. The host address range will be from plus 1, which is 225, up to 254, because 3 ones and 5 ones, it will be all ones, 8 ones, which is 255. Alright? That is how you subnet a network. That's how you divide a network into subnets. Alright, based on the previous example, you can pause the video and do this 2 exercises. And after trying them, check with the following results that I will show you. So example 2, it says determine the network and host address of the following IP address. So given an IP address, the question is to determine the network address and host addresses or usable IP addresses in the network. To do that, what we do is we take this IP address and determine the subnet mask. If it's not given, usually it's given, but we can't even determine the subnet mask if we are given the IP address. So the given IP address is 192.168.5.85, which in binary is, alright? The subnet mask that we can derive from this IP address is, and its binary equivalent will be 24 ones and 8 zeros. Now the question, if you remember, is to determine the network address and host addresses. One way to do that is using a binary operator AND. Alright, now if we apply AND on these 2 binary numbers, we find network address. If we apply the AND binary operator, 1 and 1 is 1. Any value ANDed with 1 is the value itself, so we can copy all these values and paste them, because any value ANDed with 1 is the value itself. Again, using another property which says any value ANDed with 0 is 0. We have 8 zeros. Alright, so the AND operation of the given IP address and the subnet mask, these 2 binary numbers, we find this IP address, which is the network address to which this IP address belongs. Alright, now the host addresses in this network will be network address plus 1, so it will be 192.168.5.1 up to .254. Right? So the question was determine network address and host addresses given this IP address, so that's what we have done. For the second example, given same IP address, divide the network to which this IP address belongs to 2 subnets. For each subnet, find the subnet mask, the network address, the broadcast address, the range of IP addresses, range of usable IP address or host addresses. So it's the same kind of question. The difference is in example 2, we weren't asked to divide the network into subnetworks or into subnets. Alright? So given an IP address, determine the network and host addresses was the question. In here, given the IP address, divide this network to which this IP address belongs into 2 subnetworks. And for each subnetwork, we are asked to find the subnet mask, the network address, the broadcast address, range of IP addresses, range of usable IP address or host address, like the example I have done previously in the 8 subnets. So pause this video and do this example and check your results with mine. So it's the same IP address, which is 192.168.5.85, which in binary is So we're asked to divide this IP address into two subnets. So let me draw supposedly a circle which doesn't look like a circle at all. So this is subnet 1 and this is subnet 2, which is 1. So we are taking 1 bit to divide a network into two subnets. We can take just 1 bit, so it will be 2 raised to 1, which is 2 networks. That's what we are doing. So we are dividing it into two. The first network with the bit set to 0 and the second network the bit set to 1. So this is the given IP address. Now the first question for each subnet, for subnet 1, A is determine the subnet mask. So this is a class C network, which means its natural mask would be this. So the idea is we are taking 1 bit for the subnet, which implies the new subnet mask. If you take 1 bit from the host bits or from the host ID is, so this as it is, if you set this 1 and 7 zeros, that's 128. So the new subnet mask for each subnet would be 255.255.128. Alright, B, the question was network address. Network address for subnet 1 will be all these numbers dots. So since this bit is set to 0 for subnet 1, what we do is 0 and we set the remaining places to 0, which will be dots, just to save time, dot 0. These numbers 192.168.5.0 is the network address for subnet 1. Question C is broadcast address, which is this 10 and the remaining bits 1, which is 7 ones, 127. Question D is range of IP addresses, range, just total IP addresses in subnet 1. So that will be from dot 0 to dot 127. E, host addresses or range of usable IP addresses. So that will be the network address plus 1, which is dot 1, 192.168.5.1 to dot 126, because this is the broadcast address. Dot 127 is the broadcast address. The last host address in subnet 1 would be -1. Alright, 126. For subnet 2, similarly, A is the same number because subnet mask for all subnets is the same. B is network address for subnet 2. So by setting this to 1 and setting the rest to 0, we will have the number dot 128. 1 and 7 zeros is 128. So this is the network address for subnet 2. And its broadcast address would be, if we set this to 1 and the rest to 1, which is 255. D, range of IP addresses. So the range of IP address would be from network address to broadcast address. So from dot 128 to dot 255. E, usable IP address or host addresses for subnet 2. As I said previously, network address plus 1, which is 129. And for the last host address, we deduct 1 from the broadcast address, which would be 254.